In this video, we'll observe some chemical changes of matter. In fact, we are going to use chemistry to cause this wooden board to levitate. First, Dr. Lyle will add a small puddle of water to the board. Next, he's setting the ordinary empty beaker on the puddle. Now he's adding a substance called barium hydroxide to the beaker. Barium hydroxide is a base, and you might not have heard of barium hydroxide, but you probably have heard of acids and bases. You can see that it's a solid, a nice white powder. Next, he's adding another solid white powder, a compound you're probably not familiar with called ammonium thiocyanate. It is an acid, and some of you know that acids react with bases. So we're going to stir it up and perform an acid-base chemical reaction. This particular reaction is an unusual reaction because it occurs between two solids, and often solids tend not to react very quickly with one another. What do you observe happening to the mixture as he's stirring it? Did you notice that it is getting kind of slushy or wet? This is because water is a product of the reaction. Water is a common product in many acid-base reactions, although not in all of them. If you were in the same room as this reaction and up close to it, you would probably observe the smell of another product of this reaction called ammonia. We could certainly smell the ammonia when we were filming this demonstration, which must mean that some of the ammonia is in the gas state so that it can reach our noses. The chemical reaction has progressed, and now Dr. Lyle is going to magically levitate the board by picking up the flask. How do you think the board will also be lifted? If you look carefully, you can see a lot of frost forming on the outside of the beaker. What does that tell you about the temperature? That's right, the temperature is below the freezing point of water. The water is freezing because the reaction inside of the beaker is absorbing energy from the surroundings, including the water puddle that was put on the board. Because the water is now frozen, we know that the temperature must have gotten below 0 degrees Celsius. Actually, it gets down to about minus 12 degrees Celsius. That's very, very cold. This type of reaction is called an endothermic reaction. An endothermic reaction absorbs energy from its surroundings. This is exciting. We've used a chemical change, the reaction between two solids, ammonium thiocyanate and barium hydroxide, to make another substance inside the beaker, such as water and ammonia, and we could observe those substances. The chemical reaction inside the beaker absorbed heat from the surroundings to freeze the water puddle under the beaker. The liquid water puddle freezing was an example of a physical change because the frozen water is still water. So there was a chemical change inside the beaker and a physical change underneath the beaker. To summarize, in this video we observed two changes. A chemical reaction change that was endothermic, and that was used to cause a physical change, the water freezing. And then in turn, we used the frozen water to levitate the board by picking up the beaker. Thank you for watching this video, and I hope you enjoyed the demonstration.